Okay, so today is chapter 14, section 7, and this is the last section we are doing in chapter 14, so we're going to be preparing for the chapter 14 test to start on Friday. We're going to talk about lengths of chords, secants, and tangents, and we're going to talk about what the secant length theorem does to help us find the lengths of those chords. So, first, what is the secant length theorem? Well, what it tells me is it goes along with ratios. And we've talked about how things are in proportion several times, but this is just a different kind of ratio, and what they are telling us is that if I multiply the length of PA times the length of PB, I should get the same number as if I multiply the length of PD by the length of PC. So looking here, the length of PA we know is 2. The length of PD PB I don't know right now. The length of PD is 4, and the length of PC is 3. So I substitute those numbers in to the secant length theorem. I go ahead and start solving. I get 12 on the right side and 2x on the left, so I discover that the length of PB is going to be 6. Now the second thing we can learn from the secant length theorem is the power of the circle. The power of circle P is the product of the lengths of the two segments. So in other words, it's one side of the equation. So the power of this particular circle is 12, and what the power refers to is the ratio of the lengths of the chords. So we have two chords intersecting, and these ratios are going to be equal. It also works if we have tangents or secants that intersect outside the circle. So if we're looking at this circle, PA is 3, and PB, I have to add them together. 3 plus 9 is 12. That's where the 12 came from. I added 9 plus 3, and I got 12. On this side, PC is 4, and PD is the one that I don't know. So I'm trying to first find out what PD is. So I'm going to substitute it into the secant length theorem. 3 times 12 equals 4 times something. I solve that, and that tells me that the length of PD is 9. So that makes CD 5, because PD is 9, and 9 minus 4 leaves 5 for CD. The power of this circle would be, well, it's missing. The power of this circle would be 36, because one side of the equation is 36. So the power of circle O is 36. Here's another example. It's asking me to find out what the length of PB is and the power of circle P. So I just look at my numbers. PA is 2. PB is the one that I don't know. PD is 4. And PC is 5. So I substitute those in. I do the calculation, and that tells me that PB is 10. The power of this circle is 20, because 4 times 5 is 20. Again, it's just one side of the circle. Okay, now what if we have a tangent? Can we still use something along the lines of the secant length theorem for tangent? And yes, we can. It's called the tangent length theorem. And what it tells us is, with the tangent length theorem, what I do is I find the distance from the point to the circle, and I square it. So in other words, it's PT squared. So let's go down here and look at this example. Okay, so I want to find out what is the distance between the point of tangency on the circle and the intersection point G. And then I also want to find the power of the circle. So I'm going to set it up. It's going to be 3 times 9, because I used the whole thing. So 3 times 9, and then I use the length of GE squared because I would be multiplying GE times GE. Okay, I'm going to work it out. GE squared equals 27. So GE is the square root of 27, which is approximately 4 or 5.196 or 596 thousandths. The power of this circle would be the 27 because 3 times 9 is 27. So that's the secant length theorem and the tangent length theorem as it applies to the power of the circle. Okay, this is just another example. It's actually the same example as I did right in the beginning. If you would work this one out, you should find out that x is going to be 4 because, 3 times 12 is 36. I need to know what this is and this, so I would need to find it. This one's would work. You'd have to do a little bit more work to figure out, but this answer would be 9. So you would just be working out the power of the circle. Okay, so do the assignment that is on your homework sheet, and I will see you tomorrow.